So how was she able to express? Okay, so negative 5abc minus 2a squared plus 6abc. So what I'm gonna do is I am going to actually, okay, so you read the whole thing, and now I have to make sure that everybody understands this. Okay, right here. So let's see, binomials. Sure. 5abc plus 6abc is 11abc, and then you have minus 2a squared. Now we usually write terms starting with the largest exponent, so this would be actually negative 2a squared plus 11abc, and that's basically what she said. So your job now is you're going to simplify each of these expressions and see if they end up as binomials. So good luck. So let's see now. This is the product rule. So 5x squared, 5x to the third times 2x squared is 10x to the fifth, right? So this is, let me see now. This is 10x to the fifth, right? Minus 10x to the fourth plus 3 times x to the fifth times, plus 3x times negative 2, That's easy. Alright, so what I'm gonna do is I'm gonna get some extra paper because I don't have extra paper at all, and I don't want to be doing all this. Or maybe I can, if I have space, I will do it. So let's see now. Minus 10x to the fourth then, oh my god, then 3x to the fifth, okay, plus 3x to the fifth, and then plus 3x times negative 2x to the fourth, that is minus 6x to the fifth. Okay, and now we have the like term, so 10x to the fifth, 3x to the fifth, and negative 6x to the fifth. So the whole thing can be as 10 plus 3 is 13, 13 minus 6 is 7, so this is the same thing as 7x to the fifth, okay, 7x to the fifth minus 10x to the fourth, minus 10x to the fourth. And yes, this is a binomial again. Okay, now try this one. T plus 2 and the whole thing squared minus 4t. You already know what t plus 2 to the second power should be, right? T plus 2 times t plus 2. And now you multiplied each and everything, right? So you get t times t is t squared, so t squared plus 2t, because you multiply by everything, right? Now 2 times t is 2t, and then 2 times 2 is 4. And then of course the one that we forgot is minus 4t, because we forgot. So then again, 2t, okay, t squared, we're gonna have t squared, right? And then plus what, 2, 4, oh wow, 2t plus 2t is 4t, minus 4t is 0, so we just get plus 4. Okay, I get it. And this is what we got. All right, I'm not gonna do any more for you because this is that's not the point. We still got a long way to go. So what I'm gonna do is you guys are going to work on the rest of the problems. Just make sure that you could see them. And anyway, you have a handout, so that shouldn't be a problem. Let me go and look for a charger for the camera, which I should have somewhere in here, because the camera is going to die, and if it dies, we cannot do anything about it. So continue working with the problems while I untangle this thing and hope that the dog will not eat it. Okay. Oh my god. Oh, this is crazy. And where is this thing right here? Okay. So we Gucci. Okay, we continue with the recording. Now this is crazy. So where was I? Okay. Remember, and I'm just gonna guide you, okay? You gotta use the distributive property here. 5 times a is 5a. So you better write that down over here. Then 5 times -1 is -5. Right? So you have 5a minus 5. And now we gotta use the distributive property over here. -10 times a is -10a. And then -10 times -1 is +10. Negative times negative is positive. Plus 100 times a minus 1. Okay, 100. Positive 100 times a is positive 100a. Then we have positive 100 times -1 is -100. And now, my friends, you're going to add the like terms. I'm not going to help you with that. Let me help you with the next problem. So we have 2 pi r minus pi r squared times r. Guess what? It doesn't matter where this is. Look, you have -10 parentheses, so you have to multiply. Well, here you have parentheses and then you have the number or the letter. Guess what? This still implies multiplication. It doesn't matter whether the r is here or at the end of the parentheses. You're still gonna have to multiply. So then let's do it. So pi times r. Let me see if I can find. Okay, you know what? I'm gonna give you, take like a minute or so to work on this problem. Remember, you gotta use the distributive property. So you're gonna have to multiply r times 2 pi r squared. 2 pi r, and then r times pi r squared. Then guess what? This is also distributive property because it's parentheses multiplied by 2r. So it doesn't matter where the 2r is. The 2r could have been over here, and you still have to distribute it. So you're gonna multiply 2r times this and 2r times this. So take a couple. Take your time, multiply. I'll be back in a second, okay? Okay, so I'm back. I took a break and I'm back. So let's see if we understand. I am going to write it in a separate piece. Let me see. You cannot see them. Okay, that's what you have, right? So r times 2 pi r squared. Well, remember something, that the r is not going to multiply the 2, is not going to multiply the pi. The r is going to multiply the r. So we have 2 pi r to the second power. Positive times negative, negative. So r times pi r squared is going to be pi r to the what power? Exactly. Finally, you're getting it. Now, we're going to do the following. We're going to switch this to pi r. I'm sorry, this 2r. We're going to switch it over here. Because we still have this. You know what? Forget it. I'm just going to write minus. And then 2r times 2 pi r. Well, I have a 2, so I has got to go with the 2, right? So it has to be 4. Pi is not being multiplied by anything, so it's pi. R times r is r squared. And now, remember, this is kind of difficult to explain. I should have explained it before, but it's okay. I wanted to put this 2r over here to make it minus 2r. Why is that? Because if I was to put the 2r over here, then it would have been negative 2r times negative this, which will give you a positive. Because if I do it right now, you're gonna call me crazy, but I'm gonna have to put parentheses around it. Okay? And now 2r times negative pi r squared is negative 2 pi r squared. Okay, and that's what you get. Now we need to remove parentheses, so I am going to write a little smaller. So I have 2 pi r squared minus pi r to the third minus 4 pi r squared, and then look, plus 2 pi r squared. Now I'm gonna have to combine like terms. So I have this with pi r squared with pi r squared. So let's see now. 2 pi r squared plus 2 pi r squared is 4 pi r squared. 4 pi r squared minus 4 pi r squared is 0. We got issues here. Something did not come out right. Okay. Minus 4 pi r squared. Okay, something is not right. Okay, so you know what? Easy. If it's not right, I'm gonna have to rewrite the expression. I'm gonna rewrite the expression. 2 pi r minus pi r squared, okay, times r. But this time I'm gonna put the r over here. Minus 2r. I'm putting the 2r in front of the parentheses. Minus 2r times 2 pi r minus pi r squared. Okay. That's basically what I have. Let me see if you can see this. So that's what I have. Right? Okay. Okay. So now let us multiply. Let us multiply. R times 2 pi. Okay, I forgot the r over here. Then pi r squared minus 2 pi r squared 2r. Okay. Let's see where my mistake was, because if I made a mistake, I made a mistake. I'm not perfect. So r times 2r squared. Okay, so this is 2 pi. Okay, 2 pi r squared minus pi r to the third, okay, minus 4 pi r squared plus 2 pi r to the third. Ah, beautiful. I see what my mistake is. I forgot about this. Okay, now let's combine like terms. So pi r squared with pi r squared. So that is negative 2 pi r squared. Negative pi r to the third with 2 pi r to the third. Negative 1 plus 2 is 1, so plus pi r to the third. Okay, that was the mistake. If you still don't understand this problem, don't worry, I can always explain to you. Okay, this was a long example. This is not my idea of adding polynomials, but good too. All right, so Janie, now let's go with Janie. What does Janie want? So Janie writes a polynomial expression using only one variable, right? X with degree 3. Max writes a polynomial expression using only one variable, x, with degree 7, exponent 7, exponente 7. What can you determine about the degree of the sum of Jane's and Max's polynomials? Uh-oh. Who's writing to me? Oh, somebody. Okay. Let's see now. Oh, sorry guys. What can you determine about the degree of the difference of Janie's and Max's polynomial? Oh, come on. I thought it was something like very difficult. Alright. So basically what I can determine is the maximum degree could be 5. The degree of the sum of Janie's and Max's polynomials. Remember something. Janie writes a polynomial expression using only one variable, x, with degree 3. Then Max also writes a polynomial expression using only one variable, x, with degree 7. Now, if we start adding the polynomials, right, what can you determine about the degree of the sum of Janie's and Max's polynomial? Okay, so let me write it down. Oh, no. What am I doing? His degree is 7. Oh, no. So the maximum degree, it could be 7. Right? Oh, my God. How could I be wrong? Okay. B. What can you determine about the degree of the difference of Janie's and Max's polynomials? For B, okay, so I'm sorry, this is not part of the answer. The answer is just the maximum degree could be 7. And guess what? What can you determine about the degree of the difference? If they subtract them, the degree would be what? Well, if you have x to the 7 minus something, you have to have x to the 7. So the degree would still be seven. I don't know what I was babbling about. Anyways. Alright, so let's see now. Okay, number 3. So it says, boom. Oh, okay. So suppose that Jenny writes a polynomial expression using only one variable x with degree of 5. And Max writes a polynomial expression using only one variable with degree 5. Okay. What can you determine about the degree sum and Jenny? Please. We know that the maximum is going to be degree 5, so that's what you write. And what can you determine about the difference? Well, that the difference could also be a degree 5 or maybe anything less than degree 5, but definitely degree 5, so that's what you're writing here. All right. So let's see now. Time for you to get to work on this. Let me see now. Oh, okay. Remember, you have to show your work. You have to attempt each of these problems. Don't just copy the answer because you're not going to learn. And when you get the test, you're going to fail it. You have to show work. I'm just doing this out of comparison. We already learned how to add them. Here you have to use the distributive property. Remember that. So you have to show work. If you need to use a separate paper, then that's fine. Okay, let's see now. Finally, we're done with that one. If you have any questions, please, you could text me, okay, send me a comment, or just, if you're my student, just ask me personally, like what's going on, and I'll really explain to you what happened, okay? So I'll see you on the next episode of How Do We Pass Our Common Core Algebra class, subject / regions. All right, bye-bye. Got you.